Finally, let's take a quick look at navigation problems. The interesting thing about navigation problems and the way they're different from traditional angle or vector problems is that we measure our directions or describe our directions differently. A bearing is an angle measured clockwise from north instead of counterclockwise from the horizontal axis. So 0 degrees is due north, 180 degrees is due south, 90 degrees is east, and 270 degrees is west. In drawing the situation, we have to really think about these new angles. But the nice thing is that the math, when we work with horizontal and vertical components, works out exactly the same. So here's an example. Victoria walks 90 meters due south. So let's set up some axes here. So she's going to walk 90 meters due south. That's straight down. Right? We'll say that's 90 meters. And then turns and walks 40 meters more along a bearing of 250 degrees. 250 degrees would put us close to the horizontal here. Here is 180 degrees, so almost 270 degrees. So we're talking about that direction, but from over here, where she had walked from. So she's going to walk 40 meters there. And we want to find her resultant displacement vector, which means if we started here, we ended up here. So we think about the triangle we've formed, and we can solve this via triangle or components. Let's solve it with components. So we break down our two vectors. Our first vector, let's call that A, is going to be 90 cosine 180. I plus 90 sine 180 J. And our second vector, B, is going to be 40 cosine 250. I plus 40 sine 250J. If we add those two together to get our resultant vector, we should get a vector of negative 103.681 I plus a negative 37.588 J. Now to find the magnitude of R, again, we use the Pythagorean theorem, so negative 103.681 squared plus negative 37.588 squared, all square rooted, and that's approximately 110.284. To find the angle, we start by taking the inverse tangent of the vertical over the horizontal. So negative 37.588 over negative 103.681. And that gives us a measurement of 19.927 degrees. But because we're using two negative sides, our angle should be placing us in the opposite quadrant from 19.927 degrees. So we have to add 180 degrees. We're using the arctangent concept here. So we have 199.927 degrees to be our direction angle, which if we look at our picture, we can see that yes, we should be greater than 180 degrees from our original starting point of 0 degrees. So the bearing would be 199 degrees, and the magnitude is 110.284 meters. To find the bearing, or the starting point's bearing from the place where Victoria stops, so looking in the opposite direction from where we stopped to where we started, basically to get there we would simply have to turn around or add 180 degrees to our original bearing so that we're moving in the opposite direction. That gives me 379.927 degrees. But all bearings should be within 360 degrees. So we find a coterminal angle by subtracting 360 degrees, and we end up with a bearing of 19.927 degrees. Let's recap. What is a vector? Well, a vector is information that has two characteristics, a direction and a magnitude. How do we draw these vectors? Well, with arrows. And how do we name their distinguishing characteristics? Well, we draw from start to finish with an arrow at the finish line. So the finish line is called the head. The start is called the tail. So from tail to head. What is a scalar quantity? It's a quantity without direction. It has a single characteristic, an amount. What are two equivalent terms for the length of a vector? Absolute value and magnitude. How do we depict the idea of the length of a vector? With the absolute value bar signs. How do we add two vectors visually? We connect the vectors head of the first vector to the tail of the second vector in the sum. How do we add two vectors geometrically or algebraically? Well, after we've connected them, we've created a triangle, and we're solving for the third side of the triangle and the angle associated with it. What is a unit vector? It's a vector with a length of 1. How do we depict unit vectors in the horizontal and vertical directions? The horizontal unit vector is the I vector, and the vertical unit vector is the j vector. How do we resolve a vector into horizontal and vertical components? Well, we use the formulas that we've determined, where the horizontal component is the magnitude times the cosine of theta, and the vertical component is the magnitude times the sine of theta. Finally, how are navigation problems different from traditional angle or vector problems? Well, the difference is on how we describe the direction. Instead of using 0 degrees along the horizontal and moving counterclockwise, we use 0 degrees as due north and move clockwise around the circle.